I'm going to show you how to do Edexcel A-Level Maths from June 2019, Paper 1, Question 13. My name is Sunil Tanna. I am an author and tutor. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. Don't forget to subscribe and like this video. As you can see, question 13 is quite a long question. There isn't much space to show the question and solution on the same page. So what I've done is I've cut the question up into different sections and we'll do each section on a separate page. So the first part of the question here begins. The curve C with equation y is equal to p minus 3x over 2x minus q times x plus 3, where p and q are constants, passes through the point 3.5, and has two vertical asymptotes with equations x equals 2 and x equals minus 3. You can also see that x is allowed to be any real number except for it can't be minus 3 or 2. So part A1, explain how you can deduce that q is equal to 4. So vertical asymptote will occur when the bottom of this fraction is 0. In other words, either of the factors in the bottom is 0. So we can say that. So part A1, vertical asymptotes occur, let's write that again, occur when 2x minus q equals 0 or x plus 3 equals 0. And we can see that the x plus 3 equals 0, the solution for that is x equals minus 3. So x plus 3 equals 0 gives the asymptote at x equals minus 3. Therefore, 2x minus q gives the asymptote at x is equal to 2. So if we substitute that in, 2 times 2 minus q is equal to 0. So this gives us 4 minus q is equal to 0, which gives us q is equal to 4. Okay, part 2 of the question. It says, show that p is equal to 15. We know that the curve passes through the point 3 across a half up, so all we have to do is substitute that into the equation. So y is a half. We have on the top p, which we don't know the value of yet, is p minus 3x. X is 3, so 3 times 3 is 9. On the bottom we have 2x, which is 6, minus q, which we've already established is 4, times x, which is 3, plus 3. So that becomes a half is equal to p minus 9 over 2 times 6 over 12. So timesing both sides by 12, we'll have 12 over 2, or 6, is equal to p minus 9. So therefore, p is equal to 6 plus 9, which is 15. And that completes part 2 of the question. Okay, now we move to part B of the question, and we are given this curve, which we'll notice has a vertical line at 3 and this region R. Let's see what it says. Figure 4 shows a sketch of part of the curve C. The region R, shown shaded in figure 4, is bounded by the curve, the x-axis, and the line with equation x equals 3. So we want the area between 3 and wherever the curve crosses the x-axis, in other words, when y is equal to 0. Now, if we go back to the original equation, we had y is equal to 15, remember that was the value of p, minus 3x over 2x minus q, which was 4 times x plus 3. So we can see that y will be equal to 0, will give us x is equal to 5, because in order for y to equal 0, the top of this fraction has to equal 0. So this this area stretches from 3 across to 5 across. So area R is the integral from 3 to 5 of y dx. Of course, y is this rather nasty fraction, which is difficult to integrate in its current form. Now, when you see a fraction like this, you should be thinking about, and you want to integrate it, you should be thinking about partial fractions. So what we want to do is we want to split up 15 minus 3x over 2x minus 4 times x plus 3 into two fractions of the form a, some unknown constant over 2x minus 4, plus b, again another unknown constant over x plus 3. And the reason I'm using the identity or triple equal sign is because this is supposed to work for all values of x. So what I can do is make a common denominator on the right hand side here. So I'm going to times the first fraction by x plus 3. So I will have a times x plus 3 and the fraction by top and bottom by 2x minus 4. So it'll be b times 2x minus 4 over that same denominator of 2x minus 4 times x plus 3. Now if I times both the left here and the right here by the denominator, I will end up with 15 minus 3x is the same as a times x plus 3 plus b times 2x minus 4. And now remember, that's supposed to work for all values of x. So what I can do is I can put in particular values of x and work out what a and b is. So in this case, what I'm going to do is to get rid of the first one, I'm going to say if x equals minus 3. So if I put in if x equals minus 3, I will end up with 15 minus 3 times 3, which is 24, is equal to 0a, and then it will be 2 times minus 3, which is minus 6, minus 4, minus 10b. So this gives me b is equal to minus 10b. So b is equal to minus 2.4. I can do the same thing if x is equal to 2 to get rid of this one, and I will have 9, 15 minus 3 times 2 is 9, is equal to, so I'm putting in 2 here, so it'll be 5 times a, and this one would be 0, so 5a. So that tells me a is equal to 9 over 5, which is 1.8. Okay, so now I can do the integral here. So the area R, using that, I'll write it up here, will be the integral from 3 to 5 of the y written in this form. So I'll have a is 1.8, so 1.8 over 2x minus 4, minus b, which was 2.4 or minus 2.4 over x plus 3 dx. And what I can do is I can do this as two separate integrals. And what I want really is to make it so that when I differentiate the bottom, I will get the top. So what I'll do is I'll rewrite the integral in this form up here. So area R is, so the first integral, because I want 2 to be on the top, I'll write 2 over 2x minus 4 dx, and 3 and 5. And what I want to do here is, it should be 1.8, so what I need to do is divide by 2 and times by 1.8. So I can put here 1.8 over 2 in front of it. Likewise here, the second integral, I'll write it as a minus and do the integral from 3 to 5. I want 2.4 on the top. So what I'm going to do is divide by 2.4 and divide by times by 2.4 and divide by 1. And here it will be 1 over x plus 3 dx. And now you see here, if I differentiate the bottom, I get the top, so I can use the reverse chain rule. So when I do this integral, I'll have 1.8 over 2, or 0.9, times natural log of 2x minus 4, minus 2.4 natural log of x plus 3, again the reverse chain rule applies, with the limits of 3 and 5. Now I need to just put those limits into the integral. So I've got here, first of all, putting the 5 in, I'm going to have 0.9 natural log. 5 times 2 is 10, minus 4 is 6. And then I'm going to have minus 2.4, and then I'm going to put the 5 in again. It will be natural log of 8 here. And then I'm going to put in 3 here. Of course, it will be taking away, so it will be minus 0.9. Natural log of 6 minus 4 is 2. And then putting the 3 in here, that one's a minus minus, so it will turn into a plus. And it will be 2.4 natural log of 6. Okay. Now, if you look at the question, they want it in the form of natural logs of 2s and 3s. So what I'm going to do, first of all, is combine these two natural logs of 6, which is going to be 3.3 natural log of 6. Now, the 8 here I can think of as being minus 2.4 natural log of 2 cubed. And then I'll be able to bring the 3 outside and make that natural log of 7.2, 2.4 times 3 of natural log of 2. And here I'm going to do minus 0.9 of natural log of 2. Now, what about the log 6? How can I make that into a log 2 and a log 3? Well, if you remember 6 is 3 times 2, I can split that into 2 separate logs, a natural log of 3 and a natural log of 2 added together. So I could write this now as 3.3 natural log of 2 plus 3.3 natural log of 3. So, because 2 times 3 makes a 6 if they were in one log. Here I'm going to bring the 3 outside the log, so it would be minus 7.2 natural log of 2, and then minus 0.9 natural log of 2. Yep. And then if I add that up, I've got, for the natural logs of 2, I've got 3.3 and a minus 7.2 and a minus 0.9, which if I put that all together comes to minus 4.8 natural log of 2. For the natural logs of 3, I only have this one, which is 3.3 times natural log of 3, so 3.3 natural log of 3. So in the form it's written, A was minus 4.8 and B was plus 3.3, and that completes the question.